A giant electron accelerator feeding a chip megafactory sounds like science fiction, but it is a real semiconductor idea. The important correction is this: SpaceX has not publicly announced a free electron laser for Terafab. What follows is the documented plan, the engineering case, and the evidence still missing. Terafab is the proposed Tesla and SpaceX semiconductor platform. Official filings describe an ambition to put lithography masks, logic, memory, and advanced packaging inside one closed-loop plant, with one chip family for vehicles and Optimus and another optimized for space. That makes lithography the strategic bottleneck. The most advanced chips use extreme ultraviolet light to print microscopic patterns on silicon. More stable light and more usable power can mean more wafers per hour, better economics, and faster iteration. Tesla's own Terafab hiring is conventional so far. A current lithography role calls for qualifying EUV and deep ultraviolet scanners, including ASML or equivalent equipment, plus photoresist processes and an in-house mask shop. No job posting identifies a free electron laser. So why is the laser idea credible at all? Because a free electron laser, or FEL, is not a fictional ray gun. It starts with packets of electrons accelerated to enormous energy. Those electrons pass through a long sequence of alternating magnets called an undulator. They wiggle, release light, and organize into an exceptionally bright, coherent beam. Tune the system correctly, and that beam can reach wavelengths useful for advanced lithography. The real company to watch is Xlite. In June 2026, the U.S. Department of Commerce finalized a $150 million CHIPS award supporting construction and demonstration of a first-of-its-kind free electron laser prototype at the Albany Nanotech Complex. Xlite says its architecture could replace today's laser-produced plasma light source. The company claims up to 4 times more EUV power and says one external accelerator could deliver light to as many as 16 scanners. Those are targets, not proven production results. If those targets survive real fab testing, the fit with Terrafab becomes fascinating. A campus designed at enormous scale could place the accelerator outside the clean room, distribute light to multiple scanners, and use higher throughput across a vertically integrated manufacturing loop. The motion would be industrial, not cinematic. Electron bunches racing through accelerator sections, magnetic fields steering the beam, mirrors routing EUV light, robotic stages moving wafers, and metrology systems correcting each process step. But size is also the problem. An FEL requires major power, cooling, shielding, vacuum systems, precision controls, and near-perfect uptime. A prototype can demonstrate physics and still remain years away from economical high-volume semiconductor production. There is another reason people connect these dots. SpaceX wants chips designed for orbital computing, while Terafab is supposed to shorten the loop between chip design, fabrication, packaging, and deployment. A radically different light source could become a long-term advantage if it truly raises output. Still, a strategic fit is not a signed deal. No official SpaceX, Tesla, Xlite, Commerce Department, or SEC document reviewed for this video says Terafab has selected Xlite, ordered an FEL, or committed capital to build one. The best evidence actually points to 2 parallel tracks. Terafab recruiting for established EUV and deep ultraviolet tools, while Xlite develops an alternative source in Albany. They may converge one day, but that convergence is currently a hypothesis. Here is the investor checklist. Watch for a named light source partner, scanner integration tests, construction permits for accelerator-scale infrastructure, disclosed power and cooling requirements, prototype reliability data, and an actual capital commitment. Bottom line, a free electron laser could be one of the most consequential upgrades imaginable for a giant semiconductor campus. It is technically plausible, publicly funded at the prototype stage, and strategically interesting for Terafab. But it is not a confirmed SpaceX plan. That distinction makes the story better, not weaker. The engineering race is real. The Terafab connection is the question. Subscribe to SPCX Investor for the documents, milestones, and manufacturing signals that can turn a futuristic thesis into a verified project.